You know that feeling? It's not just hunger. It's a craving that hits you like a tidal wave. Suddenly, your brain feels hijacked by the thought of a warm cookie, a salty chip, or a slice of pizza. You can't focus. Nothing else matters. That feeling isn't a lack of willpower, it's a biological storm in a specific circuit deep inside your brain. It's the very same reward machinery that can drive addiction. But what if you could turn down the volume on that signal? What if you could hack that circuit and quiet the noise? For years, scientists have understood the gut's role in hunger. But groundbreaking research is now revealing a far more profound connection between a new class of medications and the brain itself. These drugs aren't just for weight loss. Many users report they are silencing the constant, intrusive food noise that millions of people experience. And for the first time, scientists are beginning to understand how, with new theories pointing to a tiny, ancient part of the brain that may be fundamentally changing how we experience cravings. This is the story of how science is rewriting our relationship with food, moving the conversation from a battle of willpower to a matter of biology. The problem, a hijacked brain. For decades, the narrative around overeating and weight gain has been dominated by one simple, and punishing, idea: willpower. The message was to just try harder, to resist temptation, to fight your own biology. But this fundamentally misunderstands the problem. For many people, the issue isn't just physical hunger, it's a powerful, neurologically driven urge to eat. This mental chatter is now widely known as food noise, the constant, intrusive, and often obsessive thoughts about food. It's the brain's reward system gone into overdrive. Ultra-processed, hyper-palatable foods, designed to be intensely rewarding, can trigger a powerful response in our brains. This isn't just about taste, it's about neurochemistry. When we eat these foods, our brain releases dopamine, a powerful neurotransmitter involved in motivation and desire. Dopamine is often called the pleasure molecule, but that's not quite right. It's more accurately the motivation molecule. It's what drives you to seek out a reward. When you see a food cue, an advertisement, the smell of a bakery, your brain anticipates the reward and releases dopamine, pushing you to get it. Over time, these learned associations can become incredibly strong, creating a cycle where the cue triggers a craving that feels almost impossible to ignore. It's a biological process, not a moral failing. And it's this exact cycle that a new class of medications, known as GLP-1 receptor agonists, seems to be disrupting in a profound way. The mechanism, the GLP-1 brain hack. Explained: GLP-1 agonists, like semaglutide and tirzepatide, were first developed to treat type 2 diabetes. They mimic a natural gut hormone called glucagon-like peptide 1, which helps regulate blood sugar and signals a feeling of fullness. For years, it was believed their main effect on weight loss came from slowing down digestion, making you feel physically fuller for longer. But as millions of people started using these drugs, a surprising and consistent story emerged: the food noise in their heads went quiet. The obsession was gone. Food simply lost its power. This sent researchers scrambling to understand what was happening in the brain, and the answer appears to be far more complex and fascinating than simple fullness. GLP-1 receptors aren't just in the gut, they are found throughout the brain, including in key areas of the reward pathway. Recent preclinical research has provided some tantalizing clues. Some scientists are focusing on a primitive part of the brain linked to emotion and desire called the central amygdala. The working theory is that when GLP-1s activate this region, it may send a signal that reduces the release of dopamine in response to pleasurable food. In other words, the drug doesn't block the ability to eat or enjoy food, but it might turn down the wanting. The motivation to seek out the reward is blunted. However, it is important to remember this is a hypothesis based largely on animal studies, and the exact mechanism in humans is still under investigation. This suggests a potential dual action that makes these medications so effective. The satiety pathway: the drug still signals to your hypothalamus and brainstem that you are physically full, reducing homeostatic, or stomach, hunger. The reward pathway: the drug also appears to act on the brain's reward circuits, dampening the dopamine-driven motivation that leads to hedonic, or pleasure-driven, eating. They seem to address both the physical "I'm hungry" and the mental "I want it." The donut on the counter doesn't scream at you anymore, it just sits there. This breakthrough is especially significant with the arrival of oral GLP-1s. While injectable versions have been around for years, the development of effective pills marks a major shift in accessibility. One such drug is orforglipron, a non-peptide, small molecule pill approved by the FDA on April 1, 2026, under the brand name Foundayo. Unlike some earlier oral versions, it can be taken without strict food or water restrictions, making it more convenient for daily use. Another high-dose oral version of semaglutide for weight loss was approved in late 2025 and launched in the US in early 2026. If you're finding this look into the brain's reward system fascinating and want to stay updated on how science is changing our understanding of health, take a moment to subscribe and hit the notification bell. We dive into topics like this every week. The implications, from weight loss to addiction. The practical result of quieting food noise and dampening cravings is significant, clinically proven weight loss. By making it biologically easier to consume fewer calories without feeling constantly deprived, these drugs reframe weight loss from a battle of willpower to a manageable medical treatment. The clinical trial data for these oral medications is impressive. In the ATTAIN-1 phase 3 trial for orforglipron, Foundayo, participants without diabetes taking the highest dose lost an average of 12.4% of their body weight, or about 27 pounds, over 72 weeks, compared to just about 2% in the placebo group. Similarly, results from the OASIS-4 trial for high-dose oral semaglutide showed a mean weight loss of 13.6% at 64 weeks. These aren't just numbers, they represent a fundamental shift in a person's relationship with food, driven by changes in their brain chemistry. But the story doesn't end with weight loss. Because GLP-1s appear to act on the brain's fundamental reward circuitry, the implications could be much broader. The same dopamine pathways that drive cravings for hyperpalatable foods are also implicated in substance use disorders. This has led researchers to ask a tantalizing question: if these drugs can reduce the craving for food, could they also reduce cravings for alcohol, nicotine, or other addictive substances? The early evidence is intriguing, though still preliminary. Anecdotal reports from patients on GLP-1s reporting a sudden disinterest in their evening glass of wine or morning cigarette have become widespread. Now, formal research is trying to catch up. Some observational studies have found that people taking GLP-1s have a lower incidence of developing alcohol use disorder. More directly, small clinical trials have begun to explore if these medications can reduce alcohol consumption. For instance, a major clinical trial was announced in July 2026 to evaluate semaglutide as a treatment for alcohol use disorder in veterans. It's important to be clear, GLP-1s are not currently approved as a treatment for addiction, and much of this research is still in its early stages. But the initial findings are promising. They suggest that these medications may not be targeting one specific behavior, but rather an underlying mechanism of craving itself. They appear to blunt the pull of the reward, making it less compelling. We are at the beginning of a paradigm shift in how we understand and treat conditions driven by the brain's reward system. For decades, the struggle against intense cravings was often seen as a personal failing. What this new science suggests is that it's largely a matter of neurobiology, of circuits and signals that can potentially be modulated. Medications like oral GLP-1s are not a magic cure. But they are a powerful new tool, one that appears to work with our brain's wiring rather than against it. By engaging deep brain regions to turn down the dopamine-driven wanting, they are quieting the noise for many people and giving them back a sense of control. This research moves us beyond a simplistic eat less, move more mantra and into an era of personalized, biologically informed medicine. We are learning to hack the very circuits that can hold us captive. The conversation is no longer just about willpower, it's about science. And for millions of people, that changes everything.